All right, so last time we had gotten to this point right here where we had been solving this differential equation. And what I'm going to start to do from this point is finish solving for W. So I know that there's a lot of variables hanging around, so it can be kind of difficult to like keep track of the thing you actually want to solve for. But remember, we're solving a differential equation for W because it's related to U. And we want to solve for U because it's going to tell us what y2 is. So just kind of keep in mind the order of the things that matter is going to be W, then U, then y2. And so I'm going to need some natural log properties here. I can move my constant inside the natural log like that. And then I can move the natural log sum into a product like that. Those are two properties that we covered in our little review videos because those will come up quite a bit. And then I can take exponents of both sides to get rid of the natural log around wy1 squared, just because I want to solve for w, so I would like to try and isolate it. And e to an integral plus a constant is just a constant times e to that integral. That's another thing that we've seen quite a bit. And then I just know that w is equal to some constant e to the minus integral p dx over y1 squared. And you can imagine that if you had p and evaluated this integral, you might have had like another constant. You know, maybe p was like x, so you would have integrated x dx and gotten 1/2 x squared plus a constant. But that would just get eaten up in this constant right here. So it would all turn back into having one constant out front and some function of x right there. And then from here, all we're going to do is just undo everything that led to this step. And take us back to actually looking at solutions y2 to our differential equation. So continuing our example, I promise this is like the longest example we'll ever do in class. Since we had gotten to w by saying that w is equal to u prime, if we want to get back to u, we know that u would be the integral of w with respect to x. So u is the integral of some constant times e to the minus integral of p dx over y1 squared dx. And I'm going to show you sort of our solution real quick, and then also what will happen if you add another constant in at this step. It just becomes kind of messy, so I don't want to confuse things right now. But y2 was equal to u times y1, so that's just going to be y1 times the integral of c e to the minus integral p dx over y1 squared dx. And the general solution, y equal to c1 y1 plus c2 y2. Which is y1 integral c e to the minus integral p dx over y1 squared dx. And at this point, you would have been given y1, a function of x, at the start of the problem. P is in your differential equation. So all of this is stuff that you can solve. So you do have the answer to the problem. What I want to note here is that you should not, every time you have a reduction of order problem, jump to this step and use this formula. You should follow the steps the way that we learned. to actually solve the problem, not use the formula. Because the formula isn't itself a very helpful thing. It solves one type of problem, and anytime you're not solving that type of problem, it's useless. Whereas practicing this process is actually practicing a lot of important skills. So I want to just take a second real quick to show you what happens if we add in a constant when we're integrating this function right here. So if when you integrate u, you end up with plus a constant, then you're going to have, when you plug it back into y2, you get plus a constant. And so you're going to have plus a constant right there. But that plus a constant is just, oops, hold on. It's right there. That plus a constant is actually just going to create sort of that new constant is times y1. So it just goes into your first unknown constant right here. And then you're still left with c2 y1 times that integral c e to the minus integral p dx over y1 squared dx. So it doesn't really do anything. These c's, in the end, you want to only have two of them. So this weird sum of a bunch of things, you would just call it c again anyhow. So really just all that matters is if you integrate and add constants at every step, that's fine, but they're going to get eaten up. Well, I'll leave that there. It'll be kind of confusing if you're not watching the video, but if you are watching the video, it makes sense. Maybe just some warnings. At the end, make sure you only have two constants. So even in that final solution that I wrote, I hadn't done that all the way. You're just going to want y equals c1 y1 plus c2 y2, which is just y1 integral whatever, with no, I'll write it all the way, with no extra constants. So I took that c and I just swallowed it up into that c2 that's in front, like that. And then don't cancel out your y1s early on, well, before integration. So you can't say y1 integral e to the minus integral p dx over y1 squared dx is equal to the integral e to the minus integral p dx over y1. That's not okay, so just don't try to move that y1 inside the integral. And I'm not sure if there's any other really big tips. Oh, I'll write again, don't use the formula. Because I just care that much that you don't use the formula. I know these problems are very long, but I promise you're learning more skills by practicing them than by using the formula. And real quick, maybe back in your notes where we wrote down this general approach, it might be good to note when we're solving for u of x, we need to use w equal to u prime. That's actually the reduction of order that the whole approach refers to. So with the list of steps and the warnings, hopefully you're equipped to solve this type of problem. We're going to do a concrete example where we can actually evaluate all those integrals right now.